Hey everybody, so in this video we are going to review sigma notation and talk about the value of some well-known sums. Okay, so let's just start with what sigma is. Okay, so sigma is a Greek letter, okay? Specifically, this is what uppercase sigma looks like. Okay, and in math we use it to denote the sum. Okay. So we use the letter I or the letter K as the index. Okay. In general, I use I, but you will see that some of the MyOpenMath homework prefers the letter K. Okay. So if we look at an example of this, okay, this would mean that the index goes from 1 to 5. Okay. So let's look at understanding some examples of sigma notation, and then like I said, we'll review a couple examples of sums that we know the answer to. Okay, so this says that we are looking at the sum from 1 to 5 of just the index itself. Okay, so the index is going to start at 1, and then it goes to 2, 3, 4, and 5. And remember, sigma means that we are adding these all together. Okay, so it is going to be the sum from 1 to 5. Okay, let's go ahead and look at another example. Okay, so now we are looking at the sum of I squared. Okay, so this is going to start with 1 squared, and then 2 squared, 3 squared, and 4 squared. Okay. So this is the idea of how we can change between a sum and the sigma notation of that same sum. Let's look at one more of these. Okay. Now, a lot of times, like we've talked about in class, computer science people like to start the indexing at 0. Okay, so if we start at 0, what are we going to get here, right? The first number is 0 plus 1 or 1. Okay, the second number is going to be 1 plus 1 or 2. Okay, the third number is going to be 2 plus 1 or 3. Right? And then 3 plus 1 or 4, and then 4 plus 1, which is 5. Okay, so you can actually see that this is exactly the same as part A, right? So what we're seeing here is that there's multiple different ways to write this as the sum, right? We can have the sum from 1 to 4 of I plus 1, right? And this is exactly the same as part A, right? The sum from 1 to 5 of just I. Okay. So depending on how you choose the index, it might look different. Okay. Let's look at one more here. Okay. Now we're looking at the sum from 1 to 5 of xi. Okay, now this is how we normally see the index used, right? Just to number different values of x, right? We even see it with linear functions when we talk about x1 and x2 when we're doing the slope, right? So what this would mean is we have x1 plus x2 plus x3 plus x4 plus x5. Now we can't know what number value this would be, but we do know that it's the sum of these first 5 x values. Okay, all right. Let's go ahead and look at some more complex examples that are more similar to what we're going to use the sigma notation for in class. Okay, so like I said, this is something that we'll see why we're talking about this specific sum in class, okay? But we want to look at what this is going to be equal to, okay? So again, we're going to start with just the first term, and we know that that means that I is 1. So this is going to be x1 times f of x1. Okay. Then my second term is going to be x2 times f of x2. Right, so it looks like we're doing x value times y value for each one of these. Right, so my third term is x3 times f of x3. And my last term is x4 times f of x4. Okay. So again, this looks like x value times y value for each of these different x's. Okay, let's look at one more example, which is pretty much exactly the sum that we're going to be looking at in class the most. Okay, now in this example, delta x doesn't have anything to do with the index, right? It's not like xi where the index changes as you go. Delta x is just whatever delta x is. So each term is going to have delta x, and then we will change the index. So I'll have f of x1. Okay, then the same thing is going to happen for the second term. I'll have delta x times f of x2. okay? Then delta x times f of x3, then delta x times f of x4, and then delta x times f of x5. Okay. Now, if you really wanted to, you could certainly factor out delta x here, right? So I could write this as delta x times f of x1 plus f of x2 plus f of x3 plus f of x4 plus f of x5. Okay, now this is something that you actually see with any sum. If you have a sum, right, where you have something like a constant, okay, so in this example, what we have is a constant times f of xi. We can actually factor that out of every single term, right? So it turns out to be that constant times the sum. Okay. And that's what we're seeing here, right? We're seeing this as delta x times the sum from I equals 1 to 5 of f of xi. Okay? So all this is saying is that if you have something that's not affected by the index, right, it's a constant, then you can factor it out of the sum, and you see why here, right? It appears in every term, so you can just factor it out. Okay? All right. Now, the other thing that we're going to need to remember for class is a couple of sums that are well known what the answer is. Okay, so I just want to remind you of what they are so that we can use them during class. Okay, so we are going to be looking at the sum from 1 to n of I, which would just be 1 plus 2 plus 3 plus 4 up to whatever number is at the top here. Okay, and you can show that this turns out to be n times n plus 1 over 2. Okay. The second one that we're going to use is if we look at the sum of squares, right? So I squared, this would be 1 squared plus 2 squared plus 3 squared plus 4 squared up to whatever number n is. Okay, and this turns out to be n times n plus 1 times 2n plus 1 divided by 6. Okay, now the last one, and this one isn't used as much, but it is still something that we might use during class, so I want to make sure we know the answer to this, is the sum of cubes, right? So we're going to have 1 cubed plus 2 cubed plus 3 cubed all the way up to n cubed, whatever n is. Okay, and this is going to be n squared times n plus 1 squared over 4. Okay, an alternate form of this is n times n plus 1 over 2 squared. Okay, so those are the three most common sums that we need to know. Okay, and those are the ones that we'll probably use during class. All right, so I appreciate you guys watching this video at the last minute, and I will see you in class.